Hey, good morning or good afternoon. Mr. Myers here. As I mentioned in class yesterday, there is a good chance that I would not be in today, and that's why you've got a video key. So we went through this pretty quick yesterday, talking about the scientists and what their contributions were. We talked about isotopes and their notation and structure, where we saw things like protons and neutrons and electrons, mass number up here, and atomic number. And in third hour, I did not get to talk about charges, and so you can correct that today. And in sixth hour, we did talk about charges briefly. So I just wanted to go through some things top to bottom and then let you see the key and see how you did. And when you're done with that and you're working on the working class, you can converse with those around you to find out, hey, if I didn't get this one and I'm confused, but someone over there got it right, well, talk to them, find out what you missed and go from there. Also, as a reminder, which your so kind substitute teacher who's here today in my place is going to remind you that there are resources on the Google site, which I'll just go from there for now, because why not? I'm doing a screen share. And under Unit 2, so Honors Chem 1, with click on Unit 2 if it comes up. There we go. Unit 2. And we scroll down slowly to the videos. You'll see the pre-lab video you're going to see in a little bit is right here. And then the video you could have watched over the weekend, no, on Monday. On Monday night was this one here. And then with last night's homework and what you're working on today, this video here is a very good source. Isotopes and average atomic mass, number 3. So if you get a chance later at home or on your phone or what have you, if you need to go back and watch it, do it. All right, so I'm going to go back here to the Hangout and then back to my hover cam here and get in big. Okay, so at the top it says atoms are made up of protons and neutrons. Both of them are found in the nucleus, and then electrons are in the surrounding electron cloud. So we didn't really talk about the electron cloud too much, just to say that with quantum theory and quantum mechanics, that there's a probability of where that electron exists somewhere around the atom, and that would be particularly within the electron cloud, and that is also in your course pack. It says the atomic number here is equal to the number of protons, and then the mass number is equal to the number of protons plus neutrons. We talked about that yesterday. Highlighted, I say here that in a neutral atom, the number of protons is equal to the number of electrons, and that's key. It must be a neutral atom for the protons and electrons to equal. But you'll notice on some of these problems, you encountered a charge, and an element or substance that has a charge is subsequently called an ion. Okay, and this charge indicates an imbalance. So it's an imbalance between protons and electrons. It says if there are too many electrons, then you're going to have a negative charge, and if you have too few electrons, a positive charge. So for charges, I'll put it right here. What we're doing is we're comparing the electrons versus the protons. So ideally, if you have a neutral atom here, your electrons and protons should be the same. If you have a charge, however, if you have a positive charge, this means you are losing electrons. Think about it. An electron is a negatively charged subatomic particle. So if you're losing or taking something away that's negative, you're going to become more positive, just like that attitude. And if you're gaining electrons, that means we're gaining or adding something that's negative. We're getting more negative than we're going to be negatively charged. Okay, and that part comes into the electron column here that you were to solve for. All right, now going across at the top here, we've got the element or ion symbol, the atomic number, the atomic mass, mass number, protons, neutrons, and electrons. So let's go left to right. In the case of hydrogen up here, the atomic number of hydrogen, according to your periodic table, here, this is the hydrogen. The atomic number is the number at the top. So I would put that here. The atomic mass is this value right here, 1.01. So that non-whole number value at the bottom of each element box on the periodic table, that is the atomic mass. And so that's what we would expect for that isotope. So 1.01. The mass number, in the case of the mass number, for right now, go ahead and round the atomic mass to the nearest whole number. So as you went through on atomic mass, for mass number, either round up or round down, depending on your rounding rules that we learned last unit. So the mass number of hydrogen in this case is 1, based on the atomic mass of 1.01. The number of protons, remember protons is the same as the atomic number. We said that up here. Atomic number equal to the number of protons. So we just copy that over from there to here. And then our neutrons, remember protons plus neutrons is the mass number. And if we know the mass number in the column here for each element, and we know the protons, courtesy of the atomic number, then subtracting the two will tell us the number of neutrons. So you can do that math. And then finally, the electrons. If it is a neutral atom, like in the case of H, then the atomic number, the protons, and the electrons are all the same value. All right, but what if we get something like H+? The atomic number is still 1. Remember, the number of protons and atomic number, that identifies the element that you're working with. So if that number changes, then we no longer have hydrogen. The atomic mass stays the same. The mass number is, so it's still 1. Protons is still 1 from the atomic number, neutrons still 0, but now the electrons. We had an H+. Remember, plus means we're losing electrons. So if we start with 1 proton and we're going to lose an electron, which was the same value there, then now we're going to have 0 electrons. Okay, you can take a look at the next one here. Okay, if you need to have this paused, just raise your hand and ask politely that it be paused. Okay, you can see for carbon, because it's neutral, there's no charge. The protons and the electrons are the same value. For lithium, the positive charge means that we're losing an electron. So we're going to have 1 less electron than we do protons. And for chlorine, 17 protons, but that negative charge here, that's a -1. So it's +1, +1, -1. Okay, that -1 means we're going to gain an electron. Whenever you see charges like the +3 or +2 down below here, that's the number of electrons gained or lost. When it's just a plus or minus and there's no number there, we imply that it's 1. Okay, you can see magnesium +2. That means we are losing 2 electrons, so we should have 2 fewer electrons than protons, hence 10. Okay, the next 3, take a moment, take a look there. And the last 2 at the bottom. You have the silver +1, so we're losing an electron compared to before. So everything going across is identical, but we have 1 fewer electron than before. Okay, sulfur is a -2 charge, So where we had 16 protons, we would have predicted 16 electrons, but it's -2, so we're gaining 2 electrons to get 18. Okay, so now I'm going to switch over to the backside to average atomic mass. Okay, we did this at the end of class yesterday, and for 6 hour we talked about the weighted average, how your class score or your grade in class is determined, right? We said you have a 70%, so right up here, 70% is your test scores, 20% is your labs, and 10% would be your homework scores. So let's say you're getting, yesterday I think it was 95, let's say you're at a 92% on your tests. Okay, so it's 92 out of 100. Labs, let's say you're getting them all in and you do them all correctly and you ask questions and you did them right. You get 100% on that. And homework, you get them in every time. Okay, that 10% might bite you in the butt if you don't do it. So looking at that, we would say, all right, well, these are all out of 100. So really we'll call it 92, 100, and 100 there. So for average, or the weighted average here, if I have a 92 score, I'm going to multiply that by the 70%, but in decimal form. All right, in doing so, once I find my calculator, should get you 64.4. And then 20% or 0.2 of 100 is 20. And 10% of 100 is 10. And so if we add these all up, you get 94.4. That means your weighted average in the class, your total overall grade, is a 94.4%. So doing the labs correctly and doing the homework on time and completed, that can help you with your grade even if your test scores are a little bit lower than your weighted average. Okay, now we look at isotopes. Okay, we have up here, it says elements come in a variety of isotopes, meaning they're made up of atoms with same atomic number but different atomic masses. These atoms differ in the number of neutrons. And remember, neutrons have mass, so mass will be different. Okay, so those are going to be different. The average atomic mass then is the weighted average of all the isotopes. And so the example that's given, a sample of cesium is 75% of 133 cesium, 133. This right here is the mass number of cesium, as is this 132. So we've got 75% of 133 cesium, 20% of 132 cesium, and lastly 5% of 134 cesium. What is its average atomic mass? Well, we have an idea that it's going to be pretty close to this 133 when we do the math, because it's 75% abundant. Okay, that means that of all the cesium in the world, when you take a sample of cesium, 75% of it is going to be this isotope, 20% this isotope, and 5% this isotope over here. Okay, so to find average atomic mass, we'll change our percentages into decimal form. So move the decimal point over 2 places, make it decimal form, and multiply that percentage by the mass number. In this case, we get the 99.75, the next one 26.4, and then the bottom 6.7. Once you find those weights, add them up, and we get 132.85. And AMU, okay, this is AMU, this is the unit for average atomic mass, which A and M, average atomic mass. Okay, so that's how we go about it. So let's take a look at the key below. We did this one in class today, at least in third hour. So average atomic mass of this mixture of isotopes, iodine, 127, 126, and 128. 80% of the time it's 127, so our value is going to be pretty close. And so I do the math, change my percentages to decimal, times the mass number. I get my weights, and I add them up. I get 126.86. With the unit, it's 126.86 AMU. Well, take a look here. On the periodic table for iodine, we're at 126.90, which means our calculations are pretty close. Okay, so you did good there. Going to the next one, with gold AU, what's happening? 50% 197 AU and 50% 198 AU. Again, 0.5 times the mass number for each case. Get the weights, add them up. 197.5 AMU, atomic mass unit. Okay, remember, do not forget your units. Without a unit, it's meaningless. Okay, here are the next two. 15% 55 iron, 85% 56 iron. Okay, we find the weights right here, add them up, boom, 55.85 AMU. In fact, check this out. On the periodic table, iron, 55.85 AMU. Going on to number 4 and 5. Okay, 4 is with hydrogen. Okay, just for fun, H1 is hydrogen. H2 we call deuterium. And H3 we call tritium. Just some interesting knowledge that you now have. You're welcome. Okay. But we can see 1.012 AMU. Your periodic table says 1.01, so we're close there. Number 5, we get 14.07 AMU, which your periodic table says 14.01. Boom, 14.01. Don't let a few hundredths of a value trouble you. It's okay. So right towards the bottom there. So 6, I'll move this up. Carbon, they say 98%, carbon 12, 2%, carbon 14. Do the weights, add them up. 12.04 AMU, which is close enough to your periodic table value. Okay. Again, if you have questions over this, find a classmate that knows what they're doing, or you can check out on the website that video that I showed at the beginning of the video. If you have headphones, feel free to put them on your phone and watch that video if you need to. Otherwise, I hope this tutorial and going through the answer key helped you. Good luck on your homework and have a great day.